In this video, we will continue with the index lifecycle management for the hot, warm, cold architecture, but we are going to leverage a new feature within Elasticsearch, which is the migration action. So just to contrast with what we've done previously, in these first two videos, we were managing shard allocation with attributes. So if you go to, let me see if I can find one of my terminal windows for my nodes. So let's take a look at this one as an example. If I look at Elasticsearch, elasticsearch.yaml, we were basically setting this attribute to, or this attribute is whatever we want to call it. It could be geo, it could be size, rack ID, whatever you want. We just chose my identifier and we gave it an arbitrary value. And if we go back to, let's say, my Kibana instance for a moment, or even I upload all our notes into a GitHub repo, so you can always reuse the command here. But you can see that we were allocating shards based on, let's see, the attributes here within our templates and also within our index lifecycle management policy. And this all works fine for in fact, it still works in the latest versions of Elasticsearch, which is what I've been demonstrating. However, in the most recent versions of Elasticsearch, they've decided to formalize this process. Let me see if I can open up the documentation. They decide to formalize the process with a new type of, or through the concept of node roles or data roles. And that's something you can configure in the elasticsearch.yaml file. So if I go to my node 1 again, so in here, right, this is completely freeform. We can choose whatever we want here. But Elasticsearch says, hey, ever since Elasticsearch 7.1, let's formalize it with data roles. And specifically, they added these types of roles: data content, data hot. In fact, there's a few more if we go to the documentation. Data hot, data warm, data cold, data frozen. So these are the new roles that have been added in the latest versions of Elasticsearch. So in the older installations of Elasticsearch, you still may see other operators or other administrators using allocation as a way to do moving shards between nodes. But in latest versions of Elasticsearch, you now have a formalized way of doing this. And I'll explain a little bit more about each of the properties of these data roles in a moment. But let me show you something interesting. If I go to Kibana and I run, let's say, this command, you can see these letters here. So these letters reflect the roles that have been assigned to each particular node. If you don't explicitly state this line here, if this were commented out, then by default, Elasticsearch assigns all the data roles to that server. But if you explicitly define just a few of these roles, then this will also reflect accordingly the exact rules that you've assigned to the node. And each of these letters, C for cold, D for data node, D for data node, F for frozen, H for hot, I for ingest, etc., etc., etc. So you can just look up this chart here. There's a chart somewhere, but you can just look up the chart on this documentation to know what how each one of the letters map to each of these roles. Okay, so that's what these roles are. And we talked a bit about master nodes and such in our video on clusters. And now we're introducing the concept of data roles. A few interesting notes is, I think these notes here are important. Every Elasticsearch node must have either these two or just the data role. In fact, I think it doesn't have to be data hot. It could be data warm or data cold. But as long as you have a data content with a temperature a data role, or just this data role. This data role, they explained it somewhere down here. It basically performs any of these Here it is. A node with a generic data role can fill any of the specialized data node roles. So if you don't want to explicitly state every single one of these data underscore role, you can just use data and that will automatically encompass each one of these. But if you're setting up a hot, warm, cold architecture, you may consider some nodes in your Elasticsearch cluster are dedicated specifically for just hot data, and another Elasticsearch node may be dedicated specifically for just warm data, and et cetera, et cetera. So in those situations, you may not want a generic data role, and instead you would want a specific role to reflect the operations that that particular Elasticsearch node should perform. And I think that's what we're going to try to do here. We're going to leverage these data roles instead of using the allocation, instead of using these custom attributes. I could choose to leave this attribute in here because maybe it does serve other purposes for your Elasticsearch cluster maintenance. So you could continue to leave this here and just choose not to use it as part of the hot, warm, cold architecture, because now you could use node roles for that. And you can see I've already typed this one in here. And what I'm saying is I don't want it to have a generic data role, but instead I want to manage data content, which is just indice content and even data stream content. Additionally, I want this server to manage only hot data. Okay, so these are the two roles that are of interest to us for this particular video. All these other roles, up to you if you want them included, and if you want it to be part of the a master node for part of the maintaining and operating the Elasticsearch cluster. That's completely up to you. For now, these are the node 1. So this is server, yes, node 1. I want node 1 to manage hot data, so I've added these two roles here. So let's do a systemctl. Oh, let me just save this document. Okay, let me save and let me do a systemctl restart Elasticsearch. And let's go over to node 2 and node 3 as well. Where's my node 2 screen? This one. Okay. Okay, and I will enable this line. And by the way, this line is something I just typed in earlier and I commented out to leave it inactive. But this one is going to have the data warm node. So we want node 2 to have warm data. And let's go over to node 3. And I am going to make this one have cold data. And you can have a fourth node for frozen data, and you can have multiple nodes sharing the same role if you wanted to, which actually is probably what you will be doing in a production environment. So while node 3 is starting up and node 2 is also rebooting, which means our cluster is down until at least one of these is back up. But I'll just get this ready. Skip SSL verification, username. Just want to see when our network is back up, or when our cluster is back up. Oh, looks like all three are back up now. Yes, all right. And going back to node 1, so you can see that these roles here have been reduced. Let's compare this with what's in our Kibana. So if you look here, previously on node 3, we had frozen and hot and warm. So FHW, but FHW is now removed from node 3. You can see here, you can see hot for node 1. Hot is in node 1 here, but the warm and cold have been removed. So W and C have been removed. So that's how you read these abbreviations or these letters. Okay, and I might as well just go over here and press run again. And you can see the roles have been updated for each one of these nodes. So at this point, all the steps going forward is very, very similar to the previous video where we set up an index lifecycle management policy. And then we create an index template and we create an index. We just adjust a few minor properties, right? So it's going to be straightforward. I'm going to start by creating an index policy. So let me just grab that from my second computer monitor and paste it into this page here. 1 second. Copy, come over to this. You know what? I can delete most of these things, I think. You know what? Actually, I will leave it here. I might want to reference it later, but instead what I'll do is I'll create a lot of space so I don't get confused. Okay, so this is our index lifecycle management policy for the hot, warm, cold policy. And you can see it's very similar to our last video where we did a shard allocation with attributes. So what we're doing here is same thing with the hot phase, minimum age 0 seconds, and we start the rollover at 5 minutes. For the warm phase, it starts at 5 minutes. Now, notice with the allocate, we no longer specify any attributes. I'll just say, let's reduce the number of replicas though, and it is my intention that when I create these indexes for just this demonstration to keep the replicas to just 0 or just 1 shard, because it makes demonstration a lot more easy to understand. But here, let's compare with over here. So this was from our last video. In our last video, when we did the actions in the warm phase, we had to explicitly say, move this shard to a node with the identifier beta. But here, we've completely deleted this in this policy because that's one of the benefits of the latest versions of Elasticsearch is that this warm phase is automatically associated with the data underscore warm role. Just like this phase here is automatically associated with the data underscore hot role, okay? And that's really the only difference. We just don't need to specify any attributes. Warm is automatically associated with any node that has data warm here, okay? And this is associated with anything that has data hot. And cold is associated with anything that has data cold. That's it. That's the only change compared to our previous video. You just remove the action for allocating by attribute. All right, so let's create this policy. I'm just going to press run. All right, and the next step is pretty much the same as our last video. We'll create an index template. I'm going to take it from my second monitor and I'm going to paste it right here. All right, so very similar to our previous video, or these two lines are the same. This line is the same. This line is also the same. The only difference here is we are, when we create a new index, automatically assign it to a tier or a tier called data hot, which means any node that has the data hot role. You will see that this is a built-in attribute of the Elasticsearch allocation. So allocation actions. Let me pull up the documentation for this again. So here is the documentation for the index level shard allocation again, and you can see one of the built-in properties is underscore tier. However, we've specified underscore tier underscore preference, and although it's not explicitly written here, you click on this link, it opens up this page, and it explains that here more. And for here, you can pick any one of these values, right? So that's what we're saying here is that the moment an index is created, automatically assign it to the data hot tier, or any node that has the data hot role in it. So I'm going to go ahead and create this template. And then let's go ahead and create our first index. Nothing unusual here. Again, this alias maps to this alias. And let's go ahead and create this. And once we create this, let's maybe add a document to this index just for fun. And let's see if what the issue is. Oh, maybe I have to do post. Okay, and let's do a quick search to make sure everything is in there. Good. All right, we have a document in here. I'll add a second document. Okay, we have two documents in here. Let's do a quick analysis. Get cat shards on the demo alias, or okay, so we can see on node 1. Actually, we should be more specific. Okay, so we know that we can see now that index 1 is on the hot tier. Let's take a look at the ILM explain. Oh, I might have to type in demo 1. What's the command again? Give me a moment. I think it's demo alias. I always forget exactly if it's at the beginning or at the end. Oh, okay, great. So yes, we see our index is currently in the hot tier, and we'll just wait. At this point, I believe everything should just still be the same, just like our previous video. We just wait for it to transition between the different tiers. If you don't want the automatic transitions or the automatic migrations, you could, in your policy, tell it to stop. So let me find the documentation for that. Okay, great. So this is the action, migrate action, only allowed in the warm and cold phases. And you can see there's only one option here. By default, enabled is true. But if in your index lifecycle management policy, you put maybe not this much, this one, this really does nothing. But if you put enabled false in here, then it prevents the actual migration in your policy. So you notice that we've completely omitted this option in our policy because it's basically implied, or it's implied. It's just part of the policy here. We don't have to state migrate explicitly. Just the fact that we are using the roles and lifecycle and this policy, all this happens behind the scenes for us. Let me just double check this. All right, so again, it might not be exactly 5 minutes. I'll pause and return every so often, but at this point, everything should just be like the last video. All right, it's been more than 5 minutes, and you can see that Elasticsearch knows to start preparing this index for rollover to a new index and to start migrating this. We'll give it some more time. It has been a few more minutes, and we can see the automatic rollover of demo 2 has happened. Demo 1 is still in the hot phase, but it'll probably make it onto a warm node pretty shortly. Yeah, it's still on node 1. Let's add a few documents quickly. 3, do a search, and we can see records are being written to the new index at this point. It has been a few more minutes, and looks like demo 1 has made itself onto the warm phase. And yes, it is on the warm node now. Number index 2 still on the hot node, but index 3 has been made, and this should be the right index now. I'll just create a new document. Actually, I'll call this 7. Let's do a search. Well, actually, it might not show up because we have a lot of records now. I'll just make this a really big number. And yes, so the new latest records are being written to the new rolled over index. I'll keep waiting to see if we can actually catch a migration into the cold phase this time. It's been several more minutes, and it looks like index 1 again has just skipped the cold phase and jumped straight to the delete phase. It's actually sitting on node 3, which is our cold server, our cold node. So maybe I just didn't press record in time to catch it while it was in the cold phase, but you get the idea. All right, so in a moment, this index will completely disappear. Right now, it probably still exists. Demo 001 right here. Okay, so we'll wait a few more minutes. It's been a few more minutes, and looks like demo 6 is up. 1 is still around. I'll just keep waiting. Eventually, 1 should disappear. Yeah, 1 is still here. Let's add a few more records. And let's do a search. Okay, records are now being written to number 6. I'll wait a little bit longer. Okay, it's been a few more minutes. Looks like demo 7 is around now. Demo 1 isn't here anymore. Let's do a quick check. Okay, yeah, so demo 1 has been deleted. Too bad we couldn't see it in the cold phase. My life cycles are probably just really short, like 5 minutes isn't really realistic of anything. So I'm just going to tear this down, tear down our experiment. Oops, okay, whatever. I'll just paste it down here. And we can start getting ready for the next video where we're going to talk about data streams. And I think we also have index number 7, 6 and 7. 6, 7. Let's get rid of our template and let's get rid of the policy as well. Yeah, so in our next video, let's demonstrate all this, but with the concept of data streams. So that will be coming up next. I need some time to prepare my notes. Hopefully I can get that video out today, but if not, it'll be coming shortly.